GATE is a competitive examination taken by millions of students every year in India. This is from the February 2016 question paper in Computer Science and Information Technology in the design and analysis of algorithms. Here is the problem. GATE 2016, Computer Science and Information Technology, Paper 1, Question 41 on the design and analysis of algorithms. It's a fill in the blanks question. Here is the problem, question 41. Q is a queue containing 16 numbers. S is an empty stack to start with. Head of the queue is a function that returns the head element of the queue without removing the element from the queue. Top of S is a function that returns the top of the stack without removing it from the stack. So here is the algorithm. It's a while loop. Let's read the entire code, converting it into a language. While the queue is not empty, do the following things again and again. The stack is empty, or if the top of the stack is less than or equal to head of the queue, then delete the element from the queue and push it onto the stack. Do this repeatedly so long as the stack is empty or the top of the stack is less than head of the queue. Once the stack is not empty, or it turns out that the top of the stack is greater than the head of the queue, then pop it from the stack and push it onto the queue. Do this repeatedly so long as the top of the stack is greater than the head of the queue and the stack is empty. Now we have to find out how many times is the while loop executed. The key we can see is here. The queue contains only the elements in decreasing order. This is always satisfied. So we are going to have everything continuously removed from the queue and pushed onto the stack. N minus n elements are transferred to the stack. Minimum element is in the queue. Now to find the minimum of n elements in the queue takes n iterations of the loop, or the n minus 1 iterations of the loop. Now what we do is this. What are the total number of iterations for n elements? First case. Transfer the top n minus 1 elements to the stack. The least of the n elements is the queue. Transfer the n minus 1 elements from the stack to the queue. Transfer the least element to the stack. Repeat the process again and again with n minus 1 elements left in the queue. What is going to be the time complexity of the algorithm? It will be Tn. Then we can say the following things. First of all, n minus 1 elements go to the stack, n minus 1 iterations at least. Least element is found in the queue. N minus 1 elements go to the end of the queue, n minus 1 more iterations. Least element goes to the stack, 1 iteration. The total number of iterations for n elements are given by the recurrence relation. Tn is equal to Tn minus 1 plus 2 into n minus 1 plus 1. We have to solve this recurrence relation. The trick is to use this n plus 1 squared is n squared plus 2n plus 1. N minus 1 squared is n squared minus 2n plus 1. We substitute for this n squared plus 2n plus 1 and I substitute over here for Tn minus 1, n minus 1 squared minus 2n plus 1. I'll say both of them will equate to n squared will be the value of Tn. So what I can do is Tn is going to be n squared will be one solution to the recurrence relation. So 16 elements we require 16 squared or 256 iterations. This is going to be the answer. The answer is 256. End of the presentation. Thank you very much for your kind attention.